So this is already all on the screen because I actually recorded part of this already, but I realized I wasn't recording my actual audio. And so, so I'm redoing this first part. So I'm going to leave this on what's on the screen, but we're going to talk through what's happening. So this is a follow-up to 3-2 from Algebra 1. Which is over zeros of linear functions. If I remember to do it, I can put a link in the iCard to that lesson if you haven't already watched the core lesson for this lesson, right? But there was a question over the homework, and I wanted to I could have just typed a response, but I think making a video is actually going to save me some time and probably be more useful to you guys. So I'm going to make a quick video answering the question. So in that lesson, in the main lesson video, we were talking about zeros of a function, specifically linear functions, because that's all we know about, zero or zeros. And we looked at a word problem. And the reason we looked at a word problem is because zeros of a function is really a concept and an idea. And it's very important that you sort of understand that concept and that idea. And I want to reiterate that here, that zero, because we're going to see zeros repeatedly throughout the rest of your math career. Zeros, and actually in your science career as well. We see zeros in physics all the time, and definitely in chemistry as well. And so it's important that we understand the idea. And so that's where we focus in the lesson. But I think when we hit the homework at this point, especially since this is probably a new thing for a lot of you, maybe all of you, is we got to get the homework, and the homework isn't all word problems, and you kind of look at it and say, well, okay, so what do I actually do here? We did all the steps. In fact, we did even more steps than it takes in that video because we had to write the equation as well. But it's since that was a word problem, and a lot of the homework is not word problems, I think we're kind of getting bogged down and stop. So let's kind of talk about what's happening. So you don't need the textbook in order to understand this video if you happen to just find this one on YouTube or something. But this is like number 11 from our homework, which is we weren't actually assigned number 11, which is why we're doing it here. Because I'm not going to do your homework for you, but I want to clarify. So what you're asked on numbers 10 through 21 in our textbook, we didn't get assigned all those, but what you're asked on those problems is to find the zero of the given function, so like this function right here, by graphing them. That's what this Y thing, I wrote all that out a minute ago, but again, I wasn't recording my audio, so here we are again. And so that's what we're trying to do. And so what I was explaining when I kind of looked up and saw what I was writing wasn't anyway, when I did it the first time, what we were about to write was what is the zeros of a function, which I did explain in the first lesson, but I'm going to reiterate it here because this is really important and it lets us know how to solve the problem, right? So what are the zeros of a function? So in brief and in short and simply put, the zeros of a function are the x-intercepts. Okay, so they are where intercept. S is in parentheses, and I said this the first time I wrote this word. We put S in parentheses because sometimes there is 1 0, and sometimes there are 0 zeros, and then later when we talk about like polynomial functions, there might be 2 or more zeros, right? But the zeros are always the x-intercepts. That's what they are. It's just another word for x-intercepts, and that is kind of a core, just basic baseline understanding, and from a vocabulary standpoint, they are the x-intercepts. Okay, so on the problems 24 through 35, which were also, some of those were also assigned, those you do algebraically, right? And so those answers you get by doing algebra, which is actually most people's preferred way of finding zeros, but it's important that we understand what they are, which is why we do the zeros by graphing first, and that's kind of the idea here. And so if they're the x-intercepts, now let's talk about why they're the x-intercepts. And I'm going to kind of iterate a piece of this that is kind of potentially preemptively answers questions for later. So for like if you're asking questions on those later problems where you're supposed to do it algebraically, so all the way along the x-axis, so all along here, what is y equal to? We didn't go up any and we don't go down any. So all along the x-axis, y equals 0. So for like the second half, this is not what was asked, but for the second half where you're supposed to do it algebraically, we stick a 0 in for y, and then we solve for x. Easy peasy lemon squeezy. But to finish answering our question here, we're going to look at doing it graphically. Okay, so how would we go about doing it graphically? What would be the steps, if you will? Well, the first thing would be to graph it, right? And so remember with our function notation, f of x is the same as y, right? For all intents and purposes. So we're graphing y equals x plus 3. That is what we're graphing. We're actually graphing f of x, and this is the f of x axis, but it's also the y axis, right? Those are the same thing, right? And so that's what we're going to graph. And so how do we graph this guy? Well, we start with the y-intercept. So we go up 1, 2, 3, and we put a dot. And then we count our slope. So our slope in this case is 1, right? If there's nothing there, there's an implied 1, and that would be 1 over 1. You can manually write it in if that helps you kind of remember what's going on. You can also just look at it, know that it's going to be 1, which is also 1 over 1, whatever way works for you there. And so we can put on a couple more dots, and we can graph those. We go from the intercept, from wherever we started with our graph, we go up 1 over 1 in this case. So up 1 over 1 again. That's plenty of dots to be getting on with. And then you connect all your dots. I'm going to do my best to hit this where I want it. And so there is our graph. So if we're finding it by graphing, what we're looking for is we're looking at for the x-intercepts, right? And so where is the x-intercept for this graph? The x-intercept for this graph is right here. And what point is that? That point is, and the points for the y-intercepts will always have a 0 for the y part, right? X-intercepts are, by definition, a point, so we need to write our answers as a point. So that's what's going. So it's always going to be 0 for the y part, and it's negative 1, 2, 3 for the x part. So negative 3 right there. So that is an additional example, kind of simpler even than the one that we did in our main lesson video, to solving for zeros by graphing. So the short answer of steps is you graph it, find the x-intercept, write the x-intercept, and that's all it is. Zeros are the x-intercepts. They are where y equals 0. Okay, so they, and they can be all kinds of different things in word problems. Since this is going to be a short video, I won't go into like a dozen and a half different types of examples, but short and simple, that's how to find zeros by graphing. Hope that was helpful. If not, let me know in the comments or on our Discord server or in class. I will see you later. As to when I'm recording this, have a good Thanksgiving.